Hey everyone, in this section we are going to talk about hypothesis testing. And probably the best example that I can give you about how a hypothesis test works is to think about a court of law. So when you are thinking about the United States justice system, we have every person kind of starts with what we would call a null hypothesis, H sub 0. All right, the null hypothesis is really what we are going to work at proving or disproving in this example. The null hypothesis in the court of law is that the defendant is innocent. Now, in order for us to get to the point of proving an alternative hypothesis, a lot of times we'll see the alternative hypothesis as H sub A, sometimes as H sub 1 or H sub 2 if there's more than one alternative hypothesis. This alternative hypothesis is the defendant is innocent. Now, in the first section, all we are going to be doing is practicing stating the null hypothesis and the alternative hypothesis. And it's really important for us to make note of a few things. And you'll see over here where it talks about formulating hypothesis testing problems. It talks first about determining the appropriate statistical measure. Are you talking about population mean? Are you talking about a proportion? Are you referring to the variance or the standard deviation? Whatever that population measure is, has to be accurately stated. And then the appropriate value in the null hypothesis. The final thing is whether it should be one-sided or two-sided. Now, when we were doing confidence intervals, we kept talking about two-sided because we were saying it could either be greater or less than. Sometimes we are referring to hypotheses where we're only interested in the alternative that it's greater or the alternative that it's less. So let's take a look at an example here. A publisher reports that 59% of their readers own a particular make of car. Now, a marketing executive wants to test the claim that the percentage is actually different from the reported percentage. In this case, a random sample of 280 found that 55% of the readers owned a particular make of car. State the null and alternative hypothesis. So notice a publisher reports that 59% of their readers own a particular make of car, right? Our null hypothesis is going to be that this is correct, that the percentage or the proportion is equal to 0.59%. Now, a marketing executive wants to test the claim that the percentage is actually different from the reported percentage. Now, normally in an alternative hypothesis, we might have something that says the proportion is greater than 0.59 or the proportion is less than 0.59. In this case, we are saying it's different, so we are going to do the proportion is not equal to 0.59. Now, the second part of this is really what's going to be used to generate the actual test for that. So here's our hypothesis. This part is where we would actually use, and that won't be until the next section where we're actually testing that hypothesis and saying, is it true or do we accept or reject the null hypothesis? If we accept it, then we say that the report is accurate. If we reject it, then we will be able to, based on whether or not we're doing a one-tail or a two-tail test, that's going to determine whether or not we reject it and then what the alternative hypothesis that we accept is. Now, a couple of things. When you work on this within the Hawks learning area, it's important to know that while you are working through here, some of these symbols you're going to find on the keypad. Now, when you are looking for the mu symbol, or the not equal to symbol. Those things I would recommend using the keypad in order to type those in, because as I mentioned, it's going to be pretty particular about this, whether or not we are are using the correct symbol. So for example, let's just say that I use P is equal to 0.59, and then down here I use P is not equal to 0.59, and I'll submit that answer. Right? You'll see in some of the next ones as I go through here, here's another 34%. That's a population again. I'm not going to worry about that one. Let's find one where it talks about the mean. A manufacturer of chocolate chips would like to know whether its bag filling machine works correctly at the 438 gram setting. Is there sufficient evidence at the 0.1 level that the bags are overfilled? Assume the population is normally distributed. Now, in this case, we're talking about an average, right? We're not talking about a variance. We're talking about this is the average setting. So I'm going to say that the null hypothesis is mu is equal to 438. He wants to know if the bags are overfilled. So in this case, I am going to be testing that the average is actually greater than 438. Notice this is the example of a one-tailed test. I have to use mu because we're talking about an average. I also have to anticipate whether it's greater or less than. Now, this 0.1, this again is going to get into later things where when we're proving it, we can prove it at different levels. A lot of times we would say that, we can reject this at the 5% level, or we can reject this at the 1% or the 10% level. But as you see, when you're working through these types of problems, you want to identify right away, what am I working with? In this case, I can see the percentage, it's a proportion. In some cases, you're going to find ones that might be variance. So I'm not seeing any in here, but you would be able to use the variance or standard deviation. So here's an example. Sample 1,500 computer chips revealed that 27% of the chips do not fail in the first 1,000 hours. The company's promotional literature, here's the claim, claims that 30% did not fail. So in this case, my assumption, my null hypothesis, is that 30% do not fail. So the proportion equals 30. And here, we want to say, is there sufficient evidence to dispute it? A sample said that 27%. Now, am I saying that I want less or less than or equal to? Sometimes it's a little bit harder. I'm going to say that since they're saying the company promotional literature claimed that 30% do not fail, I want to say, based on this, disputing their claim, I'm just going to say that P is not equal to 0.30. Now, it could be that it's higher or it's lower, right? That's really the critical thinking. Am I only looking for lower? Am I only looking for higher? Or am I looking just to disprove that? But all of those things as you're going through here, use the keypad as you're doing that in order to state these. But that's the first section, just stating the null hypothesis and then using that null hypothesis and then also stating the alternative, right? In the next section, we'll start to take a look at how to do some testing with that.